Harmonics are now being recognized as an influential feature shaping the universe without. The violin, as a harmonic resonator, can shape our emotional universe within, and the remarkable achievement of the classical masters is that, viewed microscopically, their varnishes also create a mirror image of the cosmos. There is no level of scale at which the violin does not give us something more than we have known in music apart from it. Hamlet said, "O God, I could be bounded in a nutshell and still count myself a king of infinite space." Written by Shakespeare around 1599, only 45 years before the birth of Stradivari, infinite space was just becoming thinkable to Europeans through the discoveries of Copernicus. The seeming contradiction between the tiny nutshell and the vast universe can be resolved for us if we recast that quote in Stradivari's words. "O God, I could be bounded in a bee sting and still count myself a king of infinite space." Let's travel across a beautiful corner of the Lady Harmsworth Stradivari and follow its bee sting into an unexpected infinity. In English, the purfling of a violin refers to the three narrow strips of wood, black, white, black, that are inserted around the edge of the body and meet in the corners in a mitre which, when extended, resembles the bee's thin stinger on the end of its tail. The watchwords of beautiful sculpture are flow and connection. This belly corner blends the solidity of the wood to the fluidity of the curves Stradivari has chosen. It embodies the aesthetic G.B. Morossi expressed for all Italian violins in his phrase, "la bella plasticità." The beautiful plasticity is masterfully expressed in the smooth rounding of the edges, the parallel curves of the purfling and the outer edges, and the flow over the end of the corner. To some extent due to wear, that feature is visible in all 8 corners of the Harmsworth and suggests that Stradivari himself rounded them. No visual element interrupts the flow of these shapes, so they connect to one another seamlessly. Even the highlights on the upper edges and the outer face of the corner emphasize the liquid varnish which itself still appears to flow over the surface. The bee sting, where the 2 strips of purfling converge in the corner, is neatly executed, but does not end where the wooden purfling ends. A knife cut extends the bee sting considerably farther out toward the end of the corner. The cut follows the curve of the upper purfling strip and emphasizes its slight deflection downward from the center of the corner, a stylistic nicety rarely followed by earlier Cremonese makers. Many mysteries lie hidden in this back corner. That which is not mysterious is the same graceful handling of materials and curves we saw in the belly corner. The wood is maple rather than spruce, and its structure is no longer that of vertical growth rings, but a dizzying pattern of light semicircles rising up from a darker matrix. These natural circles echo the sculptor's curves in miniature and announce our theme. 3 observations before we proceed. There is a purfling asymmetry in the strip descending from the top. The left black strip is almost twice as wide as the right strip. Had you already noticed it? There is a white spot of something visible on top of the left black purfling strip. We will explore that with the microscope. And the reflected white line at the top of the purfling strip entering the corner from the left gives the clue that Strad used black wood, not ink, to create the strip. Our assumption would be that these strips are flat on top, having been finished with gouge and scraper. The varnish over them should then itself be a smooth layer, just as it appears to be on the surrounding maple. Let's take a look. There is no lack of skill in the creation of this mitre, but an almost amusing lack of uniformity and condition in the widths of the black strips. The very thin knife cut is a flawless and delicate grace note whose red-brown accumulation of varnish extends the colors of the black purfling, which are alternately black and red-orange. The reflected white light reveals that the surface of the purfling is not really flat at all, but mountainous, with plenty of varnish following its topography. The lower right part of the photo reveals maple from which the varnish has been worn away. Its colors are yellow and a rust red, which is accumulated in the pits in the wood. This is evidently neither bare wood, nor untreated wood, nor even dirty wood. Looking more closely at the bee sting, many additional features become apparent. The myriad white reflections indicate that the surface is granular rather than smooth in texture. The yellow between the black purfling strips is varnish coating the white wood of the miter. It is composed of many bright but small points of light rising above darker and shadowed zones. The orange varnish on the wood outside the purfling is full of colored particles, the largest ones being red, with smaller yellow particles and one triangular-shaped dark green crystal in the center of the picture, just below the lower black purfling strip. Fascinating as these details are, and a source of curiosity for the varnish makers among us, the photo as a whole could be something not of this world at all, but a cosmic cloud seen through a powerful telescope. Enjoy the beauty of this sight. Few people have ever seen it before or even dreamed it was there. This bee sting will shortly make us kings of an infinite space. Hamlet also said, "There are more things in heaven and earth than are dreamt of in thy philosophy, Horatio." Who could have dreamt that this was awaiting us, a space of such mystery we cannot distinguish whether we are floating or swimming, but it is certainly no woodwork we ever crawled into before. The yellow center is of such jeweled brilliance and variety that it has become a confection covered in yellow and green diamonds. Floating above the black purfling are particles of many colors: orange, red, yellow, light and dark green, bright sky blue, black, a kaleidoscopic array. Here we enter a fiery cauldron of intense yellow and red flame, with that suddenly alien dagger descending from the upper left, its interior glowing like a bed of burning coals, the black edges coarse and scaly, with that dark eye deeply recessed and forebodingly conscious. A quieter and cooler landscape terminates the bee sting and lets us hover miles above this winter scene, with its abstract rows of plowed brown and green terrain. Later, we will put on our lab coats and analyze what we have seen from a more familiar arm's-length view, but our interstellar travels have just begun. Returning to examine the white spot over the black purfling, we can see that it is not alone, but has a companion above it and to the left of the purfling. The maple has the same incandescent color that we saw in the corner below, and the black purfling is seething with lava. As we approach it, its color appears neither white nor yellow, but light green. It has numerous tiny, luminous dots covering its surface, with intermittent maroon spots. Above it floats a much smaller green object, while above and to its right is a glowing light blue particle. The burning surface of the purfling lies below to its left. The darkness behind it is composed of a mosaic of maroon and green dots, the work of some celestial Monet on a good Seurat day. Coming closer, the maroon spots on the now yellower boulder in space look like translucent smears, clinging like lichen to its surface. Other orange particles are now visible floating around it. Shifting our position to the left, the light falling on the boulder has altered its color to white, with the maroon spots assuming an orange color. The sheer number of small orange, green, and blue particles drifting around it attests to the complexity of Stradivari's varnish formula. This final view reveals the brilliance of the tiny blue particles, pinpoints of color scintillating throughout the varnish film. The orange particles have a characteristic color, which will also help us identify them later on. Now we are ready to gaze on the cosmic bee sting that is the goal of our journey thus far. You are already familiar with the Stradivarian bee sting and its delicate knife cut, but do you know who carved the next bee sting? This one was carved by the master violin maker whom Stradivari sought to imitate, and with considerable success. Charles Ervin took the preceding photographs. This one was taken by the Mount Palomar telescope. Studying Centaurus A with telescopes at Palomar Observatory in California, Walter Bade and Rudolf Minkowski confirmed that it is a galaxy. The pair also proposed that the peculiar structure of Centaurus A, with a bar of dark dust bisecting the galaxy, is a result of a merger between two galaxies, a giant elliptical and a small spiral. The Lady Harmsworth Stradivari varnish reveals an undreamt-of cosmos of color, shapes, and flaming brilliance. The mystery of Stradivari's varnish lies in its alchemical success in mirroring the very cosmos in its minutest features. Did Stradivari realize the full scope of his achievement? The inventors of the telescope and the microscope were his contemporaries, and it is possible that he could have examined his instruments with a microscope. We have the added advantage of living after the invention of the Hubble telescope, which has seen deeper into the universe than anything before it. The discovery of the remarkable colors and complex shapes of distant cosmic structures has completely altered our understanding of the starry sky above our heads. We are also living when color photography has made possible the sharing of the wonders of the microcosmos. In Stradivari's alchemy, we have a fulfillment of Hermes Trismegistus' dictum, as above, so below. The visual field is uniformly covered with orange, black, and white speckles. Occasional white nebulae shine in the midst of the speckles. This resembles a varnish film full of small color particles. It is, however, a photo of the host galaxy of gamma ray burst 971214. In the second photo, we see the Harmsworth varnish photographed in an unworn area of the violin. The Harmsworth did not have uniformly distributed black particles in its varnish. Otherwise, it bears a resemblance to the Hubble photograph, its red fields of color converging to imitate the uniformity of the galaxy. The irrepressible, brilliant yellow background shines through even the most determined red cloak, while the few black particles, unlike those in the galaxy, are stray dust motes caught in the upper layers of the varnish. This photo is a gorgeous Impressionist painting, a Monet abstract of purple, green, beige, and light maroon. There is a very liquid flow of color among the clouds. This is, in fact, a dust storm photographed on the surface of Mars. In this picture of the Harmsworth Varnish, which was photographed in reflected light, we find the color unexpected. The green, turquoise, and lavender flow of liquids parallels the color palette and liquid appearance of the Mars dust storm. The Harmsworth surface strongly suggests a pattern formed as water flows across a shallow stream bed. The soft and rounded appearance of the surface is characteristic of Stradivari's varnishes, and many observers through the years have reported that the edges of scratches tend to soften, even melt with time, healing the worst of the damage. This photo of the Harmsworth Varnish was taken under accurate color lighting. The indistinct lower layers have an almost gelatinous appearance, the red color particles floating above them. The yellow crystal in the lower center of the photograph is the same substance we saw floating over the black purfling in part 1 of this essay. This fire-burst nebula is in the shape and the colors of a true pyrotechnical explosion. As the Hubble authors explain, quote, resembling an aerial fireworks explosion, this dramatic NASA Hubble Space Telescope picture of the energetic star WR124 reveals it is surrounded by hot clumps of gas being ejected into space at speeds over 100,000 miles per hour. The Harmsworth belly spruce in this photo resembles a giant fireball, a solar disk that challenges the energy and fiery brilliance of star WR124. How can something as monochromatic and non-reflective as the tracheid cells of spruce be transmuted into pure, fiery gold? This is the underlying varnish secret of Stradivari, a wood treatment that reflects light upward, irradiating the color particles that float above the surface and giving the violin its characteristic glow. We have been alternately immersed in a microscopic yet interstellar space, ourselves floating among massive boulders of unknown composition, beautiful in their pastel dress of soft yellows, greens, and oranges, and in fiery cauldrons giving birth to stars. Stradivari's purfling strips are irregular in width and surface, but pulsing with a glowing energy that only a celestial collision of galaxies could hope to equal. If we return from this voyage to face the daunting task of trying to imitate his fiery accomplishment, our means of discovery are limited to what our eyes can tell us. Stradivari left behind no certain written record of his formulae or procedures, and we, more than 2.5 centuries later, have only his remaining instruments to guide us back toward his distant world, his prolific workshop, and his brilliant mind. Shall we accept the challenge? The Lady Harmsworth Stradivari of 1703 was created during Stradivari's golden period, which spanned the years 1700 to 1724. It exemplifies his skill and aesthetic development at the peak of his career. Covered in a splendid red varnish, it is an excellent instrument for us to study. Our entry point is an area of damage to the rib varnish caused by a shoulder rest. That allows us to see through a piece of displaced varnish and discover its texture and contents. These regrettable dings to the rib varnish caused by the metal foot of a shoulder rest have a golden lining for us, as we can walk around inside them by means of our microscope and see things few humans have ever seen so directly. Were Stradivari's varnish hard and dry, we would expect to see sharp fracture lines where chips fell out and have a clear view of the wood underneath. Instead, this area shows no straight fracture lines at all, only zigzag shapes and a soft and amorphous center of remaining varnish. The central mass of varnish resembles a golden dog, its forepaw extended downward toward the right. We are looking directly at the forepaw in this photo. What we see is no ordinary varnish. We are treated to an amazing display of points of colored light: lavender, pink, green, brilliant white, deep maroon in the shadows. The surface is covered in colored beads. Not a single area of smooth varnish, nor a single sharp line. We have encountered Monet and Seurat again. In this extraordinarily vivid photo, we see exactly what the varnish film looks like when separated intact from the wood. Resembling the head of a seahorse, this lifelike creature, staring at us through its turquoise eye and camouflaged with red and lavender particles embedded in its glistening skin, is certain it will charm us within range. The texture is almost rubbery and delicious to contemplate. Its chewy quality and sugary composition are the clues to the complex sugars that make up the oils and resins we would expect to find in a varnish of this appearance. The color of the varnish is a yellow amber and transparent enough, even with its torn surface, to reveal the embedded color particles. No evidence of a dissolved colorant, evenly dispersed through the varnish, can be seen. Stradivari achieved the warm red color we see when looking at the violin by stirring 4 or 5 differently colored particles into his varnish medium. We might expect such a vivid color to have required a large amount of colorant, but that is not the case, as the particles are widely spaced. Something about the varnish, or the wood beneath, has made this effect possible with minimal means. When viewing the Harmsworth wood under a microscope, one is struck by the liquid appearance of the cell structures, swimming in a honey-like bath that renders the normally opaque cells translucent to the point of dissolving. There is a varnish-like something penetrating the wood and preventing light to flow around its structures. Naturally straw-colored, the wood cells have acquired red and yellow features never seen by the woodsman who felled the tree. As we have already noticed in other photographs of the Harmsworth varnish, the light is brilliant to the point of incandescence, resembling molten metal. Let's see if we have enough clues to reconstruct some of this miracle, starting from the raw wood and building outward through the varnish coats we can observe. There are 3 distinct structures visible in this planed surface of a piece of raw, untreated, and unvarnished European maple. Horizontal cells tightly crowded side by side, horizontal depressions that form long pits, and vertical fibers that have the shape of ovals running across the horizontal cells. The color of all these features is a uniform light beige in this photograph. In examining the more worn areas in this photo of the Harmsworth, a regular feature of the maple was a dark substance which had settled in the pits. It varied from red to brown and had the surface appearance of varnish. Yet the Harmsworth varnish, as we have seen, is at most amber-colored, not dark enough to create this visual effect in the shallow pits. If we assume that something other than varnish were applied to the wood first by Stradivari, which he then followed with the amber-colored varnish, we would have a starting point for a reconstruction. Arturo Pedrini, a piano and organ manufacturer in Cremona and himself an accomplished violinist, told Charles that he believed the classical Cremonese violin makers treated their instruments with something that preserved the wood from deterioration over time. If he could apply that substance to his piano soundboards, he thought they would last 400 years instead of the mere 75 or so that they held up untreated. Finding a recipe for a preservative substance in the writings of the Swiss alchemist Paracelsus, who lived from 1493 to 1541, Charles prepared it and began testing it on wood. Paracelsus had written that it could be used to treat wood and rope on sailing ships exposed to salt water. As it was not a varnish, Charles reasoned that it could penetrate the surface of the violin wood and protect it from aging. Upon studying the photos of the Harmsworth presented here, Charles recognized a favorable comparison and offers that to you now. In this first photo, his Paracelsus-inspired subvarnish has filled in the pits but has not strongly altered the color of the raw maple. Once Charles applied a coat of amber-colored varnish over this sample, the transformation began. The first varnish coat has given a yellow cast to the wood, with a growing red shadow developing in the ovals. The tiny cells that rise up from the ovals are now visible against the red background. The wood's appearance has now reddened considerably after 2 coats of varnish, neither coat having any red coloring matter added to it. The contrast between the dark pits and the surface has diminished as the surface became redder. Returning to this view of the Harmsworth varnish, the dark pits are prominent, while the light surface has an intense yellow luster, dappled by the redder oval fibers. Individual cells now stand out clearly against the red background. In hue, it falls about midway between the Ervin sample with 1 coat applied and the sample with 2 coats applied. In addition to sharing the coloristic tones of the Harmsworth varnish, the Ervin sample has developed a notable incandescence. Its ability to give heightened definition to the individual cells is also similar to the Harmsworth. The remarkable feature about the subvarnish is that its presence has intensified and reddened the varnish layers applied over it, when neither the subvarnish nor the varnish contained red coloring matter. An observable difference between the two is that the Harmsworth pits are browner than the Ervin sample. The Paracelsus recipe can be prepared so the result is brown rather than red, and that may be one explanation for the observed difference. Another may be that Stradivari used a different substance to achieve his results, and we see convergent effects due to different causes. Unless Stradivari's recipe comes to light, or chemical analysis can determine definitively what the substance in the Harmsworth pits is, we may still use this or a similar reconstruction to help us think about how Stradivari may have built up varnish layers on the violin. There remain the numerous particles suspended in the varnish for us to consider next. The black purfling brings into visible relief light-colored particles floating above it, just as the adjacent maple highlights the darker red particles. We can venture an identification of these particles based on visual information. This photo shows the widely scattered large red particles floating above the light maple. These we have noticed before. It also shows particles we've not paid attention to until now. These are the tiny orange particles flying like a meteor shower between the yellow particles and the surface of the black purfling. Let's begin with our old acquaintances, the yellow particles. Based on Cosio's Carteggio and accounts in artists' handbooks of the period, Ervin suspected that the yellow particles were orpiment, an inorganic yellow pigment used by Renaissance artists and, according to Cosio, by Carlo Ferdinando Landolfi, who lived from 1734 to 1787, a Milanese violin maker of the next generation after Stradivari. Ervin purchased a large crystal and ground it to prepare this photo of orpiment suspended in a clear varnish. The large trapezoidal piece in the left foreground has the same surface colors we noticed on the Harmsworth photos, a light green cast with traces of orange. The brilliance of these crystals that we've seen under the microscope may be the reason they were chosen for inclusion in violin varnish. Orpiment's use goes back to the beginning of the craft. Ervin photographed a large orpiment crystal floating above the black purfling on the Gaspar de Salo viola featured in the restoration section of his website. The date of that viola is approximately 1580 AD. The meteor shower of orange particles deserves our consideration next. In this photo of the large orpiment crystal, there are also numerous tiny orange particles. These are cinnabar, a naturally occurring sulfide of mercury, mined in Spain since Roman times. Like orpiment, it has been used as an artist's pigment throughout historic times. Cinnabar has a distinctive orange cast that, once seen, is easily recognizable. Charles first noticed the presence of cinnabar in the Hellier Stradivari violin in 1987. Looked at head-on with the violin held vertically in front of the viewer, there is no hint of its presence. However, once the instrument is tilted forward so its surface is seen at a low angle, the varnish suddenly turns an opaque orange, obscuring even the wood grain. This effect is demonstrable on other instruments of Stradivari, where the varnish color is not too red to obscure it. It is also more noticeable on the belly than on the back and ribs. In confirmation of Ervin's identification, Stefan Peter Greiner has recently reported that orange particles in Stradivarius varnish contained mercury and sulfur by X-ray spectroscopy, reported in the Strad in June 2009, identifying them as cinnabar. Greiner also noted the opaque effect when the violin was turned horizontally. The final particle seen in the Harmsworth varnish is a beautiful red substance that is almost certainly an organic dye. In this photo, it is the most prominent colorant visible, with individual particles varying greatly in size. The edges are not sharp, but almost seem ready to melt into the surrounding varnish. Light passes through the particles, giving them considerable luminosity, though they are not quite transparent. Also in this photo, we can discern several individual pieces of orpiment floating below the red pigment particles. Stradivari may have begun with a sealer coat of his clear varnish at the surface, followed by the light yellow orpiment coat or coats, finishing with the increasingly darker cinnabar and finally the red pigment layers. Some mixing of the various colorants, or Stradivari's possible pouring together of the contents of small bottles to conserve varnish as he progressed from coat to coat, would place individual particles of the lighter colors together with the darker ones in the upper layers. What can we conclude regarding the red pigment? In searching for a red pigment which had the characteristics of the Harmsworth red, Ervin saw that he needed a substance both soft in shape and very intense in color. It also had to create coherent particles rather than dissolve and disperse in a cloud through the varnish. Shown in this photo, Ervin's red sample has the characteristics specified from our observation of the Harmsworth: coherent particles, soft edges, translucent, greatly varying size of particles, intense color. The luminous yellow background causes the red to vibrate with energy, a key feature that makes its counterpart in the Harmsworth such a strong colorant. In this sample, there is neither orpiment nor cinnabar, so that the red pigment could be clearly isolated. Secconi favored an extract of madder root as the probable red colorant used by Stradivari. Stradivari may well have used it on other violins, but not on the Harmsworth. A photo of madder root extract, kindly supplied to Charles by Walter Macrone, will show the great difference between madder and the material Stradivari chose for the Lady Harmsworth. In this photo, the red madder is globular, very translucent, almost ghost-like, a weak red without luminosity. What then did Stradivari use for the Harmsworth red? Ervin's guess is visually very close to the Harmsworth, but there is more than one possible source for this color. Charles used one of these, cochineal, for this study. The other comes from an insect which lives on oak trees in the south of Italy, but was not available for this test. Stradivari's genius is evident everywhere one looks or listens. Here are new mysteries and treats undreamt of in our modern philosophy. In this low magnification photo are elements familiar to us and others still unanticipated from our voyages through infinite space. There is a signature piece of orpiment peeking up at us from the lower left corner. We recognize the bit of black purfling just visible in that corner. But what is this turbulent sea we are suddenly cast upon in the center of the picture? Not only is the surface irregular, but the ocean depths are seething with activity. There is not 1 square millimeter that is at rest here. Look at the constant juxtaposition of light and dark masses underneath the waves. We can discern yellow prominences, maroon depths, hints of green, and then the black particles lightly embedded in the surface, which give further variety to the scene. No single view in our journey so captures the classical Italian attitude toward art as does this. Give a modern novice violin maker the assignment to create a red varnish and cover the instrument with it. That assignment will be perfectly carried out. A very uniformly red coating, without irregularities or errors, will be the result. The classical Italian has a completely different idea. Create a patchwork quilt of harmonious color masses which jostle and grin at one another. Give them an active surface and even more active depth. Then shine a soft light over that delicious pie and never cease to wonder at its variety of flavors. Yet from the distance needed to focus clearly on this feast, say 10 inches, it looks much like the modern red violin. But oh, what a difference in the details. The light reveals that the varnish surface is no harder than the seahorse would predict. What could not be predicted is the startling resemblance between the Harmsworth surface and human skin under low magnification. Each has a waxy appearance crisscrossed with fine lines. The Harmsworth lacks only hair follicles on its way to becoming human. The cosmic comparisons to Stradivarius varnish seem as endless as space itself. Here is one that so closely resembles the surface appearance of the previous Harmsworth photo that it could almost substitute for it in our discussion. It is identified as a hydrogen cloud by the Hubble telescope. Our examination of Stradivarius varnish is nearly over for now. We have gone where only a few violin makers have ever gone before, seen and studied several of his ingredients, noticed others that we cannot yet guess at beyond their colors, greens, purples, blues. We can also say with certainty that beauty is indeed skin deep. But the Harmsworth has a fragile skin that was easily damaged when fresh. It does not adhere tightly to the wood even today. Let's examine this phenomenon to bear in mind our responsibility when handling one of these treasures. In this photo of the back of the Harmsworth, the orange-red varnish remaining has been considerably worn toward the lower right, with a large chip-out visible near the center of the photo. It is distinguished by the yellow color which tends toward gray. Yet in the lower right corner, the varnish has remained a bright yellow, though evidently worn almost to the wood. Besides the embarrassing fragility of the varnish, it has the paradoxical quality of restoring its yellow luster where it has been polished or rubbed, but gray where the depth of surrounding varnish has prevented the polishing from reaching the bottom of the chip. That gray may merely be dirt, or it could be oxidation, or even some particularly dark shellac which accumulated there but was rubbed off elsewhere. Let's close for now with another riddle, that of a possible wood treatment apart from or in addition to the subvarnish mystery. Wood treatment is the final frontier in the varnish universe and may have been the first step in the creation of the classical Cremonese violins. The great Renaissance architect Palladio advocated placing freshly felled logs in streams of running water for 6 weeks in order to wash the sugars out of the wood, making it less susceptible to the ravages of woodworm. Cremonese violin makers living only 30 miles from Palladio's home in Vicenza would have been aware of this practice. In recent years, there's been a revival of interest among violin researchers in the question of wood treatment. Let's see whether any hint or clue to the presence or nature of wood treatment can be garnered from examining this photo of spruce removed from the belly of a Del Gesù Guarneri violin during the fitting of a soundpost patch. This shaving is only 1 cell thick and resembles ice crystals more than it does wood. The long tracheid cells running horizontally in the photo are bound together by other structures oriented 90 degrees to the tracheid cells. Luminous dots of colored light are associated with the cells like Christmas ornaments, showing the same prismatic colors we have observed in the Harmsworth Varnish. Something crystalline and lenticular has been associated with the wood, seemingly transforming it into an altogether different substance than cellulose. Although the photo does not provide evidence for the nature of the treatment employed, it does suggest that something unexpected and beautiful has occurred. The transparency of the cell walls, the appearance of a crystallizing and probably cross-linking agent having been introduced, and the airy lightness of the structures revealed by the photo suggest a very intelligent treatment has been used to achieve powerful goals. Greater tensile strength, compensating for the removal of mass from the cells, with a probable attendant increase in resonant vibration. This goal would certainly be desirable and sought for by discerning violin makers. The Del Gesù cells look empty, gossamer thin, and like the strings of a harp, but even tattered, they have a magnificent integrity, evident to our intuitive eye as we study the lattice they form. The classical Cremonese violin makers were truly kings of the universe they surveyed, and that's it in a nutshell. But wait, a note of caution to anyone interested in experimenting with orpiment or cinnabar at home. Both substances are poisonous in their dry powder state. Cosio reported that Landolfi wore a bandana while using orpiment. You should take laboratory precautions in handling them, avoiding breathing or touching the powder if you grind it yourself. Once surrounded by varnish, their toxicity is greatly reduced.